Hello, dear aspirants. This is Dr. Saurabh sir's class. We are solving our National Boards of Higher Mathematics PhD paper questions. This question is from that paper. So the question says us that let V be a real vector space of real valued functions on a given set. Okay. So we have to assume that the constant functions are in V and that if f belongs to b, that's a typo in in our question. So if our f belongs to b, then our f square will also belongs to b, and that our mod f will belong to b. Okay, so pick out the true statements that our option A is if our A and G belongs to V, then FG will belong to V. And B tells us that if F and G belongs to V, then maximum of that will belongs to V. Now C tells us that if F belongs to V and P is any polynomial in one variable with real coefficients, then our PF belongs to V. So what can be done? That our all fx all fx will lie where fx equals to k, and the k will lie in V. So and our f belongs to V such that that implies our f square and this belongs to V. They told us that now we are going to evaluate the option A. So option A tells us that let our f and g belongs to V. Then as this is V be a vector space, so our f minus g and f plus g will lie there. After that, as my I am writing that as our V is a vector space. Okay. Now by the given condition, we can write that my f minus g whole square and f plus g whole square will also lie in V. Then if they lies in V, then we can write that the minus of that will also lie in V. Yeah, I can write it in another manner. Yeah, okay. The a plus g whole square minus f minus g whole square will also lie in V. So this is what we know, that will be our f square plus 2fg plus that will be my g square plus f, sorry, that is my minus, so plus 2fg, yeah, that will also be minus g square will my belongs to V. So that means what? That means we got this. As we know that our 1 by 4 is belongs to R, and this when V is a vector space over R, so 1 by 4 into 4RG will belongs to V, so our FG will belongs to V. So our option A is correct. I am gonna write it in the golden color. Yeah, option A is my true. Now we are going to our option B. Option B tells us if F and G, there is another typo in that question. So my if F and G belongs to V, then the maximum of it will also belongs to V. Okay, I'm gonna try it. Okay. So the maximum of it will be what? We know the maximum formula, no? this is my this thing, no, f plus g plus of mod f minus g by this is the formula of the maximum. So our f comma g belongs to v. So my f minus g will also belongs to v. Now, as we told, as they told in the question that our if f belongs to v, then mod of f will also belongs to v. So as we got f minus g belongs to v, so by this conclusion we will arrive to this. Yeah, and we from this thing we can easily imply that our f plus g will belong to v. So, and as by the previous case, we saw that our 1 by 4 belongs to R, the real number, and V is a vector space over R, so that can be possible. So, my in this case, the same case will be happen with my half. So, my maximum is also belongs to V. So this is my another correct answer. So I'm gonna write it with the golden color that our B is also be true. Now I am going to evaluate the option C. C says that if our f belongs to V and P is any polynomial in one variable with real coefficients, then P of f belongs to V. Okay. Yeah. Now I am taking the option C. Let our px be a1 a0 plus a1x plus dot 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 anxn belongs to okay. So now let our h of x will be what? That is my p of f of x. Okay. So then our hx will be what? Hx will be a0 plus a1 fx. Just we are just putting the fx in the position of x. So my an fx whole to the power n. So now that is f. As our f square belongs to v, therefore by a, therefore by a we can say that our f cube will also be f square. F square sorry f square into f, that will also lie in V. By our from our A we get what? F and G belongs to V, then our FG belongs to V. So by A we get F cube is equals to F square dot F, then F square belongs to V and F belongs to V. So our F square dot F will also belongs to V. So F cube and dot 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 we can easily see that our Fn will also belongs to V for all n belongs to n. Now, what thing will happen? Yeah. What is happening with my scribble pad? Okay. Yeah. Now, using this information and the fact that V is a vector space over R, we can easily see that our this thing Hx belongs to V, no? As our Fx and Fx to the power n and and all are belongs to V, so the linear sum of them will also belongs to V, as V is a vector space over R and A0, A1, An also belongs to R. So this is a linear combination of this. So this will this is a finite linear combination of the vectors of V. So our option C is also correct. I'm gonna write it with the golden color that our option C is also true. So the correct options are all of these are correct. So our A, B, C, mm, they all are true statements. Okay. Thank you guys. Hope you understood.